Yes, welcome to this class. Today we're going to look at the standard symbols of electrical installation symbols. So the very first point there is the one gun, one-way switch. One gun, one-way switch is identified as can be shown here. And you see, whenever you are naming a symbol of a given equipment, electrical equipment, we start from what you are able to see. This is called a gun, and the way is inside here. So when we talk about one way, basically it means it's only having one button. So it is one button, and it's having one way. So that is why it's called one gun, one way. And you can see it's only having one gun, and the way is one. The second component is one gun, two-way. One gun, two-way. Still the same switch can be used as a one gun, two-way. It means now the three holes are functional. But for a one gun, one way, it's only one of these holes that is functional with this common. But for a two-way, I've said, you can see this hole, and this hole are all functional. Whereby this one is called the common, this one is line 1, and this one is line 2. So basically from outside you only having one button, that is why it's called one gun. But inside we having three holes which are functional, that is why it is called a two-way. And you can see its circuit diagram. It is very important for you to be able to interpret the layout symbol with the circuit diagram, because in the exam you will be given a layout diagram, a layout symbol, or a layout diagram, and you are supposed to interpret it by drawing the circuit diagram. In the circuit diagram, you need to have the circuit symbols. So we move to the third category, which is a two-gun, two-way. In a two-gun, two-way, remember you must be having the two buttons. And remember in naming, you start from what you can see, because whenever you install this switch, you will first see this. Then you can go inside. So the first thing you name is what you can be able to see. So this switch is called two-gun because it has two buttons. So to say, two-gun, two-way. And you can see this one represents gun 1, this one represents gun 2. And all of them are two-way because the three holes are functional. The three hole in button 1 is functional. The three holes in button 2 is also functional. That is why it's called two-gun, two-way switch. So when you are writing two-gun, two-way switch, remember you can indicate these. This one represents gun 1, gun 2. And of course you can be able to see this is the common, line 1 for button 1, line 2 for button 1. This is line 1 for button 2, line 2 for gun 2, and this is the common for gun 2. We'll go to three-gun, two-way. Three-gun, two-way, of course, it must be having three buttons. Then inside you must also be having those lines. So you can be able to see we are having three buttons. And that is why we are calling it three-gun. And the inside, of course, you can be able to see this is the first gun, the second gun, and the third gun. And you can also be able to see each gun has got three functional holes. This is the common, line 1, line 2. Common, line 1, line 2. Common, line 1, line 2. So it is indicated in such a manner. Even during installation, you need to be very careful. Look at what is common, what is line 1, what is line 2. So the switch is called three-gun, two-way. And you can see the three guns. Gun 1, gun 2, gun 3. You can also be able to see how it has been drawn. We move to number 5. We have an intermediate switch. For an intermediate switch, an intermediate switch, of course, it is one gun. We are having a one gun intermediate switch. One gun because it has one button. Inside an intermediate switch, we have four functional holes. And you can also be able to see how it is drawn. This is the first hole, second hole, third hole, fourth hole. This is the circuit, the layout symbol. When you go to the circuit, you can see it has got 4 functional holes, hole 1, hole 2, hole 3, hole 4. So all those 4 holes must be functional. That is why it's called intermediate. The operation of an intermediate is very simple. It switches diagonally or horizontally. Meaning, at some given point, you will find this one switching in this manner. So, this one which was moving downwards comes up. This one which was moving up also comes horizontally. So it can either switch horizontally or it can switch diagonally as indicated on the board. So basically the most important point for you to note is an intermediate switch switches horizontally or diagonally. We move to the 6th one, is called a fluorescent lamp. I didn't come with it, but a fluorescent lamp is the tube that we normally know, and it's drawn like that. We go to number 7, which is a lighting point. A lighting point is normally represented as an X in a layout diagram. So whenever you want to draw the circuit symbol, you draw it in this format. We also have another component which is called non-switchable switch. Non-switchable switch, we have a non-switchable switch and we have a switchable switch. The difference between the two is very simple. This is called a switchable switch because it is a socket outlet which has a switch. But there are other sockets which just have this one without this switch. Meaning the moment you connect it's on always. But a switchable socket outlet, it is the one which has got a switch you can switch on, you can be able to switch off. So meaning this socket is controlled by this switch. But there are some other socket outlets which do not have any control. Once it is powered, it is always on. So that is the difference. This is called switchable single. This is called switchable single socket outlet. This symbol represents a switch. The whole of this represents a socket. But if you want to say it is switchable, then you need to introduce this gun to show that it is actually switchable. And this is the circuit diagram for that matter. We move to number 10, a switchable double socket outlet. It means this thing has to be double and it must be having a switch. So basically this is a double socket. A double socket. We move to the industrial socket. Industrial socket is represented as it is on the board. Industrial socket, we shall see it later on. It has got 3 terminals whereby you feed your life, your neutral, and your earth. We move to another interesting point, which is equipment, which is a cooker socket. A cooker socket is here. This is a cooker socket. A cooker socket has got these particular 3 points where you connect your earth, your neutral, and you can also connect your live at this particular point. So you connect your live here, connect your neutral there, and connect your earth at that particular point. So this is the layout diagram, and that is the circuit diagram. We move to the cooker connector. So I've said this is a cooker socket. A cooker connector is represented in this manner. This is a cooker connector. If you open this, this is what you're going to get. You'll be able to get this. So during your connection, you need to open these terminals, feed your wire. So the incoming comes from this. The wire from the cooker socket comes from, of course, enters from this end. The cooker itself will be connected from this point so that you can hold the cable going to the cooker. So whatever that is coming from the cooker switch comes from this point. Then of course whatever is coming from the cooker itself, of course, is connected from this other end. So this is called the cooker connector switch. I think now we need to go to the MCB. When you talk about these are called MCBs, a miniature circuit breakers. These are single circuit breaker. We are having a double circuit breaker. So once you are there, you can be able to see a layout diagram for this particular consumer is drawn like a rectangle. Then you draw a diagonal between the rectangle. Fully, when you draw it, you can be able to see we are having some common points here. We are having the earth terminal. This is called the earth terminal. The earth terminal is always linked to the consumer. You see, it is directly touching the consumer box. So that is called the earth terminal. The next terminal we have is the earth. The earth terminal, besides being connected to the box, it is not directly connected, meaning there is no direct link. You can see some plastic. It is connected using a plastic, so meaning this link is not directly in touch with this particular consumer. So that is why you can see I have not connected it close to the consumer. But the earth terminal is directly linked to the consumer box. We also have another thing here. This is the double. This is the double circuit breaker. A double circuit breaker. It is what is commonly. It is something that you will get common in the consumer box. So the first thing you get is a double MCB. From there you can go to the bus bar. In the bus bar, you can connect your MCBs. So you can now bring your MCBs here, and of course you can connect them. You can connect them like this. Take this other one. You can place them there. So basically, this is what we are calling a consumer box. A consumer box has got a double circuit breaker, and it has also got the single circuit breaker. So the double circuit breaker is a breaker that is able to break the live and the neutral. So once you get your live and the neutral from the meter box, of course you bring it direct to the double circuit breaker. From the double circuit breaker, of course, now you take it to the bus bar, or you can supply it to the single MCBs. So once you are there is another component here that I want you to be familiar with. We have something we are calling an energy meter. An energy meter is connected together with a cutout. Remember, these are properties of the supplier or the electricity board. For example, in Kenya, we have the KPLC. Whenever they are installing power in your premises, they will bring these two. This is the energy meter, and this is the cutout. So I start with the cutout. For this particular case, for you to be able to know where you connect, you need to measure. There are 4 terminals. There is a first terminal there. There is another one here. There is another one there. There is another one there. So basically, I've tried to illustrate. You might find this case whereby, remember, a meter is just a coin. You might find your life comes in through this point, leaves through the other point. The neutral comes in from this point and leaves through the other side. You might find another type of a meter whereby the points have been interchanged, whereby you can find your life on the other side, like that. And then the neutral comes here. So I'm saying you might find this your life 1 comes here, life 2 there, neutral 1 here, and the neutral 2 on the other side. So it depends essentially on the manufacturer and how it has been designed. Finally, I want to look at the structure of a cutout. The structure of a cutout is normally in this format. You can be able to see a cutout as a fuse. This is a fuse. and this is the link. So whenever you are drawing the circuit diagram for a cutout, you need to show us that you are having a fuse there, and a fuse is drawn using these diagonal lines, like that. Then you just draw it on the other side. I'm saying we are having a cutout. I'm saying the circuit diagram will be drawn in this format. On your right hand side you have a fuse. On your left hand side you can have that neutral link. So this is your neutral and this is the live. We are drawing this, the symbol of a fuse, and this is just a symbol of just a connector. So basically we are saying this fuse is represented by this, and this link is being represented by that. So basically those are some of the symbols that we'll be meeting with as we'll be doing out our installations. So we want to stop there. Thank you.